Hi everyone. So in today's lesson, we're going to talk about tests for parallelograms. Basically, this section is about using the converses of the last section. Okay. So first of all, we start with the definition of the parallelogram. And remember, we had said that a parallelogram is a quadrilateral where two pairs of opposite sides are parallel. Now, suppose you have some random quadrilateral. You come across some random quadrilateral and you want to ask yourself, is that quadrilateral a parallelogram? Well, one way to figure out if it is a parallelogram is you check to see, are the opposite sides parallel? If the opposite sides are parallel, then it is a parallelogram. So that's using the definition. Also, if the opposite sides are congruent, then your quadrilateral is a parallelogram. Similarly, if the opposite angles are congruent, then you have a parallelogram. If the diagonals bisect each other, then you have a parallelogram. Last but not least, this is one of my favorites, if just one pair of opposite sides are parallel and congruent, that's enough to say that it's a parallelogram. Okay? So that's sort of a combination of Theorem 6.9 and the definition, but you can get away with just one pair. All right, so let's do some of these proofs. First, we want to prove Theorem 6.9 that says if the opposite sides are congruent, then you have a parallelogram. We're given quadrilateral ABCD, and we're told AB is congruent to CD, AD to BC. So let's write that down. AB is congruent to CD, and AD to BC. This is the given. Next, what I want to do is I want to draw a diagonal one more time. And when I do that, I can show that that side is congruent. So BD is congruent to BD, reflexive. What I have now is a pair of sides here, a pair of sides here, and a pair of sides here, so I can show that triangle ADB is congruent to triangle CBD by SSS. Okay, once I do that, I can show that angle ABD is congruent to angle BDC and ADB to angle C right here. To DBC. So let's write that up. Angle ABD is congruent to angle BDC, ADB, DBC, CPCTC. Next, what I have here is that alternate interior angles are congruent. That means that these two sides are parallel. So when these two are congruent, it means the top and bottom are parallel. When these two are congruent, it means the sides are parallel. So next I say AB is parallel to DC, AD is parallel to BC, because when alternate interior angles are congruent, it implies parallel lines. Finally, I say ABCD is a parallelogram because of the definition of a parallelogram. Next, we're going to prove theorem 6.10, which says that if opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So we're given quadrilateral ABCD, and that angle A is congruent to angle C, angle B is congruent to angle D as part of the given. So A and C are congruent, B and D are congruent. Now, since A and C are congruent, I can say that measure of angle A is equal to measure of angle C, measure of angle B is equal to measure of angle D, definition of congruent angles. All right, next. Since this is a quadrilateral, I know that all four angles add up to 360. So measure of angle A plus measure of angle B plus measure of angle C plus measure of angle D add up to 360. And the reason is the sum of the interior angles of a quadrilateral equal 360. This is a theorem that has no name, so we just say the whole thing. Now, what I want to say next is this. Angle A and angle C have the same measure. That means here, angle A and angle C can be substituted for each other. All right? So what I'm going to say is measure of angle A plus, this is measure of angle C, but I'm going to substitute for measure of angle A, plus, I also know that B and D are congruent, so I'm going to substitute measure of angle D for this, plus measure of angle D equals 360. I can also say the same thing but substituting for the other angles. So I'm going to leave measure of angle D and measure of angle D the same, but I'm going to substitute now A for C, or rather C for A. So again, for this one and this one, I'm going to say measure of angle C plus measure of angle C plus measure of angle D plus measure of angle D equals 360. So this is clearly substitution. Now, I can add these, and I can say 2 times measure of angle A plus 2 times measure of angle D equals 360. 2 times measure of angle C, 2 times measure of angle D equals 360. And you'll see soon why I'm doing all this. This is again substitution. Finally, number 6. I can divide through by 2, and I say measure of angle A plus measure of angle D equals 180. Measure of angle C plus measure of angle D equals 180. This is division. So now look what I've done. I've said that A and D together are 180, and I've said that C and D together are 180. Okay? And because consecutive angles are supplementary, then I have parallel lines. So basically, here, because A and D are supplementary, then these two are parallel. Because D and C are supplementary, then these two are parallel, alternate, same side interior angles. So number 7 is AB is parallel to CD, AD is parallel to BC, because when consecutive interior angles are supplementary, you have parallel lines. Okay? Finally, because opposite sides are parallel, then I have a parallelogram. So 8 ABCD is a parallelogram. This is 7 and this is 8 because of the definition of a parallelogram. So when we have to prove that something is a parallelogram, we want to use the definition. So at the end of the day, you want to show opposite sides parallel. All right, let's do one more. These are fun. It says to determine whether each quadrilateral is a parallelogram. Justify your answer. We're given measures of angles here. We know two things about the measures of the angles of a parallelogram. One, that the opposite angles are congruent. Two, that consecutive angles are supplementary. So let's see here. Opposite pairs of angles here are congruent. So yes, this is a parallelogram because both pairs of opposite angles are congruent, meaning we have a parallelogram. In the case of this one, you have that these two opposite sides are parallel. These angles are, you have that these two are congruent. These angles are congruent, meaning they're alternate interior angles. So these two sides are parallel. And remember what we said, if one pair of opposite sides are parallel and congruent, you have a parallelogram. So this is also yes. Here you have one pair of sides congruent, a different pair are parallel. This is not the case. This is not a parallelogram. So none. Okay, find x and y so that the quadrilateral is a parallelogram. That means we have to satisfy the conditions and the properties of a parallelogram. Well, we're given information on sides. We know that opposite sides of a parallelogram are congruent. So I say 6x minus 12 equals 2x plus 36. So 4x equals 48. X is equal to 12. Similarly, I have 4y equal to 6y minus 42. Negative 2y equals negative 42. Y is 21. Here we're given information on angles, and we know that opposite angles must be congruent. So I say 7x equals 56. X is equal to 8. 5y minus 26 is 4y plus 4. So y is equal to 30. And we're done. Last but not least, determine whether the figure with the given vertices is a parallelogram. Use the method indicated. Okay, let's plot these. At the origin, we have B. At 4, 1, we have C. At 6, 5, we have D. And at 2, 4, we have E. Okay, so what this looks like is this. Okay. Now, the question is this a parallelogram? And we want to use the slope formula, meaning slope implies parallel lines. So we want to see whether opposite sides are parallel. Do opposite sides have the same slope? Are opposite sides parallel? Okay, well, let's find the slopes. Let's start with segment BE. The slope of that line is 2 over 1. And what about CD? The slope of that line is 2 over 1. Yes, these are parallel. And now let's look at the other pair, ED. The slope of that line is 1 over 4. And BC has slope 1 over 4. Those are also parallel. Since both pairs of opposite sides are parallel, we say BCDE is a parallelogram. For the next one, we want to use the midpoint formula. So let's plot these again. H is at negative 6 and 2. E is at negative 4, negative 3. F is at 4 and minus 1. And then you have G, 2 and 3. So here's what this looks like. Okay, if we want to use the midpoint formula, what we want to do is we want to see whether the diagonals bisect each other. Meaning, do both diagonals have the same midpoint? Because if they do, that means that one bisects the other. So do both diagonals have the same midpoint? Okay, let's see. If they have the same midpoint, it means they bisect each other. Alright, so let's find the midpoint of, oh, what is it doing? Let's find the midpoint of GE. Remember, the midpoint formula is x1 plus x2 over 2. We add the x's, divide by 2. So for GE, we're going to use these two. The midpoint is going to be negative 4 plus 2 over 2. Negative 3 plus 3 over 2. This is going to be negative 1 comma 0. All right, now let's do FH. For FH, we're going to use these two. And we have here 4 minus 6 over 2, negative 1 plus 2 over 2. This is negative 1 comma 1/2. They don't have the same midpoint, so HGFE is not a parallelogram. All right, everybody, that's a wrap. This homework is going to be due Thursday for period C.